Good day, ladies and gentlemen. You are highly welcome to Shito's Mathematics Coaching Program. Before the commencement of today's lecture, I urge every one of you should kindly subscribe to my YouTube channel. Hit on the bell in order to get the notifications of my videos anytime I drop them. Having on the board, we have logarithmic differentiation, so that is what we are going to be looking at today. So now I will try to explain what really means by this topic, then we use the explanation to solve the problem we have on the board. So now, what is logarithmic differentiation? So what we are going to look at here is when and how the function, understand, or how the function will look like before you can determine that you are using logarithmic differentiation to solve. I don't know, maybe I get what I'm saying. So now, if you have y to be equals to f of x gs, f of x gs, that is, you have the product of two functions. So it can be product of two or more. I get it. We can have more than two functions there. So far it is products of two or more functions. One particular function, that is y, is a product of two or more functions. So you can as well use logarithmic differentiation. Or if you have y to be equals to f of x g of x over h of x. Can you see that? So this is the combination of products, that is, we have as here, and division. You can see we have what? We have that we can as well use logarithmic differentiation. Also, the third one is if you have what? If you have a function to power another function, that is, when you have g of x raised to power or to power h of x, understand? So we use what? We use the logarithmic differentiation to solve. So we can see that the first one can as well use products. We can use product rule to solve this. You can use the quotient rule to solve this, understand? But the quotient and the product rule are not easy or cannot be used to solve the third one, understand? Instead of you disturbing yourself, so you use this third one. You solve this third one by what? By logarithmic differentiation, understand? So how do you use this? So you try to introduce log of base 10 to both sides of this, then after you differentiate. So let's have what they have on the board here. So let's try to solve this one. So now, having this solution, we said let what they have here, y equals to s sine what? Sine x. So if y equals to s sine x, so let's name it to be equation 1. So now from here, you can set introducing both sides by log of base 10. You have log of y equals to log s sine what? Sine x. So equation 2. So now from this equation 2, you can as well be written this as log y equals to this sine s will come down here, log what? Log s. I don't know, maybe I get what I'm saying now. So now from this equation, that is, let's name it to be equation 3. So you now differentiate with respect to s. So now differentiating this one with respect to s, so you can see that log of y will actually be 1 over y dy ds. So the reason why, because we are differentiating with respect to s, that's why we have dy ds. I don't know, maybe you are getting what I'm saying. Dy ds. If it is you are differentiating, let's say we have u. So if it is you are differentiating with respect to s, and you have phi here, let's say we have phi log phi like this, log v like this, and we want to differentiate this one with respect to u, it will be 1 over v d what? dv d what? dv du. Understand? Because we are differentiating with respect to u. Actually, we need y. Understand? So y is our independent variable, but the independent variable we want to differentiate with is what is x. You understand? So that's about that. So now we try to differentiate this one also. So differentiating this one, you differentiate this, you keep this, then we want to use product rule here. So you try to differentiate this one, that is, okay, let's say we keep this sine x, understand, then you differentiate this one, dx log x, then plus, you keep this, you differentiate this, that is log s ds into bracket ds into bracket sine x. Can you see that? So from there, so we have 1 over y dy ds equals to, so now we have sine x because we keep sine x, then you differentiate. If you want to differentiate this one, we have what? Log x, same thing as what? 1 over x. Are you getting what I'm doing? So now from there, plus, differentiate this one, you keep this one, that is log s, then you differentiate this one. Differentiating sine x will give us cos s. Are you getting it? So from there, we have 1 over y dy ds equals to, we have sine x over x, are you getting it, plus log s cos what? Cos s. So now from there we are looking for dy dx, understand? Because they said we should get the differential coefficient of this y, understand, x and s. So what are you going to do? You try to multiply both sides by what? By y. So multiplying both sides by y, we have dy ds to be y into bracket sine x over x plus log s cos s. So now do not forget that y, that is, recall that y equals to s sine what? Sine x. So now from the right hand side, anywhere you see y, you put s sine s. So we have, finally you have dy dx to be equals to, finally we have ds of x sine x to be equals to, what is our y? S sine x into bracket sine x over x plus cos x log x. So, and that is the final answer to the problem we have on the board. So try to look at your product rule of solving differentiation problem. Look at how to solve implicit differentiation. So if you know that the only problem here, or the only issue here, is to know how to take log. You understand? How to apply logarithms here. So that is all. And also to know how to differentiate, maybe by quotient rule or product rule here. So that is the solution to the problem we have on the board. If you have any question to ask, so kindly hit on the comment box and ask any question of your choice. So I promise I'm here to give you the best answer. So you have a wonderful day, and we meet some other time.